Everybody's interested in chiplets these days, but trying to get them to actually work together can be a challenge. ARM has been doing some really groundbreaking stuff. Could you tell us about your latest announcement?
Yeah, well, Bill, we're happy to be here at the Chiplet Summit talking about the public release of ARM's new chiplet system architecture specification. We really think it's important to work through a standards-based approach to be able to get chiplets that can actually be interoperable. So this idea of composing your silicon, right, using reusable chiplets can only really happen if people are building towards some common standards, right, to achieve this sort of interop vision. So we have released our first public spec just in time for the first day of the Chiplet Summit. We've had over 60 partners working with us to get the specification up to this point, and we're always looking for more partners to help collaborate with us.
Could you talk a little bit more about the underlying standards that are employed? Or is it using things like UCIe, AMBA? How does that all fit together?
That's a good question. So we're very a big proponent of standard physical interfaces. And so ARM has been even on the board of UCIe to help really promote UCIe as a viable standardized interface between chiplets. Now, what the chiplet system architecture looks at is how do you think about a system above the physical layer? So what are the protocols that would benefit running over between the two chiplets? And we're a very big proponent of the AMBA protocol, which is over 25 years old and is used in many ARM systems today. We've been able to have a revision of that runs AMBA chai over chiplets. And so we talk about that in the specification. We also talk about how to do logical partitioning. So if you wanted to have designs that use, for example, I/O chiplets, how would you partition a system where you have compute on one die, I/O on the other die as well? And then it provides a framework and terminology for system designers to be able to spec their system design around chiplets. So if you want to issue an RFI to a vendor on a chiplet, read the CSA spec. We think it'll help you in writing your RFI document.
So how does this fit with a lot of the ARM IP you have out there? Is this something that is going to make it easier for designers to incorporate that?
It will. So what we want to get to is where people talk about having compliant chiplet products to the standard. And the ARM IP will be designed to help enable that compliance as well. And so from our standpoint, we're very actively working on compute subsystems that can be used to make the compute chiplets. We're also working to expand our IP interconnect so that not only does it help connect multi-core ARM SoCs, but it also connects to accelerator chiplets as well. And so our vision is that we can end up with these chiplets that can provide coherent memory access with each other, have shared memory domains, and we think that's a really interesting and great way to compose chiplets.
I know we're just at the starting point at this point, but where do you see this going in the future? Will there be an additional organization around this to provide compliance and things of that nature?
And so, there are a couple things that we will eventually evolve the spec, right, to talk about and solve problems like how does a multi-chiplet system boot? How is it secure? How do you leverage telemetry from all these different chips, right, to do things? So we'll have future revisions of the spec that try to really tackle some of those issues. And then we are working with partners on how do we actually develop compliance programs, right? Are there test suites that we want people to run when it comes to saying that they have a compliant chiplet? That's also some of the activity that we're working on right now as well.
Excellent. Sounds like an exciting future.
Well, we want to have chiplets as easy to use as PCIe cards are today, right? And so now you bring that system level approach down into the package level. We need the same sort of standards and compliance systems in place to do that.
Thank you very much.
Thank you.